This worksheet has a few problems on there that's going to give us a chance to practice all the different reactions of the carboxylic acid derivatives, and then some of the reactions from chapter 20 also. And notice that I've got two of these reactions blacked out because they use a reaction that we didn't learn. So we're not going to do those syntheses. For all of these reactions, whenever you are starting with a carboxylic acid or a carboxylic acid derivative, which is going to be the case in all of these molecules. We're starting with an ester, a carboxylic acid, another ester, an amide, another carboxylic acid. So whenever that's your situation, you're starting with a carboxylic acid or a derivative, your easiest bet is to start with an acid chloride. Remember that the acid chlorides are the most reactive out of all of the carboxylic acid derivatives, which means that they do the most number of reactions. They're the most versatile. So it's going to be easier for you to convert an acid chloride into something else. The other bonus of always starting with an acid chloride is that you only need to remember the reactions of the acid chlorides if that's your strategy. So that's what we're going to do. We're going to practice on this worksheet. For all of these reactions, the very first thing that we are going to do is convert to an acid chloride. When we're starting with a carboxylic acid, converting to an acid chloride is as simple as just adding SOCl2. So now we're at an acid chloride. And the next thing that we want to ask ourselves is whether or not we have one step that can get an acid chloride straight to an acetal. And there isn't. That's not an option. Acetals come from the reaction of alcohols with either an aldehyde or a ketone. So what we need to do next is convert our acid chloride into either an aldehyde or a ketone, whichever would make the most sense for this case. Before we get too far, let's take a look at our carbon chain and see if there are any carbon atoms that need to be added in this process. So we can see that we've got these carbons over here that we need to add, plus we also need to add this acetal. One of the oxygens from the acetal is going to come from the acid chloride, so we'll say it's this guy right here, and we know how to get the acetal on the molecule. That's pretty straightforward. Let me actually just make that a different color. So what we need to do before we get going on the acetal, we need to figure out how to put these two blue carbons onto the acid chloride. We have a reaction that converts an acid chloride to a ketone, and that is the lithium dialkyl cuprate reaction. That would be perfect for this example because that is going to give us an ethyl ketone. So now we have all the yellow carbons, and then we've added these blue carbons in place, and so now all that we have to do is convert to the acetal. And that we will do with an alcohol or a diol, and that's an acid catalyzed reaction. So let's try this again with the next example. Remember, the very first thing that you want to do is convert this derivative to an acid chloride. So how do we convert an amide to an acid chloride? There isn't a direct step, and I will give you another tip. You always want to start with an acid chloride. The easiest way to start with an acid chloride is to convert whatever derivative you have to a carboxylic acid. They can all be converted to a carboxylic acid, and once you convert them to a carboxylic acid, use SOCl2 to form the acid chloride. And converting to carboxylic acid is the same for all of the derivatives. We're just going to be using H3O+. That's it. There's also base catalyzed versions of converting to a carboxylic acid, but This one is really easy to remember. So we're going to convert to a carboxylic acid, and then we are going to convert the carboxylic acid to an acid chloride. And see, we're doing all of this without even really thinking about what are we trying to do ultimately. We're just trying to get our derivative, the amide, into a functional group that's easier to react. I don't know why all of a sudden I made these aromatic. There we go. So now let's think about what do we actually have to do with this reaction. So here we are with the 7 carbons that we started with, and let's follow those through the reaction, and let's see where they end up in the product. So the stuff in blue, the nitrogen and that extra carbon, that's the stuff that need to be added in this reaction. We can also see that we are forming an imine, and we only have one way to create an imine, and that is with either an aldehyde or a ketone and an amine. So what we want to do, much like the previous problem, we want to do is convert our acid chloride to either an aldehyde or a ketone, whichever one would make the most sense, and then we can convert that to the imine. If we look at what we're trying to make, our desired product, and this carbon right here, there is not another alkyl group attached to that carbon, doesn't have another R group on it. So that means that we don't want to tack an additional R group on our carbonyl carbon. We would like it to just become an aldehyde. That would be ideal. And the reagent that we used to do that, I really didn't make a long enough arrow, lithium, aluminum, tri-tert butoxy, followed by water. That gives us an aldehyde. And then to go from the aldehyde to the imine, this is a reaction from chapter 20, we want to use a nitrogen that has the R group, which in this case is a methyl, and 2 hydrogens, and this is an acid catalyzed process. So it's not so bad. So let's try this next one. Remember our first job, before we really think about much of anything at all, we want to convert this to a carboxylic acid, just use H3O+. Once we get it converted to a carboxylic acid, we're going to use SOCl2 to convert it to an acid chloride so that it becomes very reactive and functional and versatile. And now let's take a look at our carbons and see what needs to happen, if anything, to our carbon chain. So we can see that we are not trying to do any addition to the carbon chain. We're not trying to make our carbon chain bigger. We're just trying to add an acetal. So what we need to do next is convert the acid chloride to an aldehyde, which will then let us convert it to an acetal. Converting the acid chloride to an acetal uses that long lithium, aluminum, tri-tert butoxy, followed by water, and then we're going to use the diol with some acid to give us the acetal.